Alright, section 7.6 deals with what's called a compound inequality. Alright, and all that is it's going to be kind of x sandwiched in between two things. We looked at it already when we talked about set builder notation and about graphing the inequalities, but now we're going to see it in the form of, an equation, but it's an inequality, okay? 7.6 again starts out talking about sets. And again, we're going to gloss over a lot of the set stuff, but just in a nutshell, if you ever take a class that has probability, these are called Venn diagrams, where you've got, set A and set B, and maybe you're interested in the overlap of the sets, or maybe you're interested in the combination of all information in the sets, and these little symbols are talking about that, okay? And again, we're not going to worry about that so much. I just want to move on to solving the inequalities. Okay, you're going to see it's almost identical to what we've been doing, just one little extra thing to think about. If I have something like example 4 on page 360. Okay, let's talk about that. Look at this thing now. I've got a 5 and a less than symbol, x plus 3 less than 12. Okay. I've got x kind of sandwiched in between two inequality symbols. So I would kind of read this as x plus 3 is greater than 5 and less than 12. It's an and situation. Okay, x is trapped in the middle of these two inequality symbols. So both of those symbols have to hold true. Okay, the word and isn't there, but it's an and problem. Okay, x plus 3 is greater than 5 and less than 12 at the same time. Okay, so I'm going to solve these simultaneously. Okay, now if it helps you, we could break it up into two complete separate problems. We could say this. X plus 3 is greater than 5, again reading it backwards, and we could write that word and. X plus 3 is less than 12. Okay, so you take it and break it up into two separate problems. And now we work them. Okay, subtract 3, so 2 is less than x. Again, we read it from x's perspective, so x is going to be greater than 2. Okay, and what's cooking over here? X is going to be less than 9. Okay, so x is going to be greater than 2, and x is also going to be less than 9. How would I show that? Well, on a number line, okay, greater than 2, not including 2, less than 9, not including 9, so I'm going to have a parentheses here, a parentheses here, and I'm shading in between. Okay, that's how I would show those numbers. Okay, interval notation, it's kind of handed to us right here on a silver platter, right? I made my parentheses too far apart, but 2, 9, they're both in parentheses. Okay? All right there? So it's an and problem. The alternative, this is kind of the way I prefer to do it, but maybe you wait until you get the hang of it, is that you just kind of work it all together right here. You say, okay, I'm going to subtract 3. So I'm going to subtract 3 here, I'm going to subtract it there, I'm going to subtract it there. I do it everywhere. 5 minus 3 is 2, keep the symbol, x is in the middle, keep the symbol, 9, and there it is. X is greater than 2 and less than 9 all at the same time, so from 2 to 9 in interval notation. There we go. Okay, so let's practice it. Okay, we'll do another one maybe separate and then see if we like the idea of combining. Part B of example 4. -7, then I've got less than or equal to x minus 7, less than or equal to 1. So again, if I'm reading it from x's perspective, x minus 7 is greater than or equal to -7, and it's less than or equal to 1. Okay, solve this problem. What do? I add 7 to both sides. Okay, solving it together here first. So add 7 everywhere, all around. So -7 plus 7, that's going to be a 0. Is less than or equal to x, is less than or equal to 7 plus 1 is 8. Okay, that's how I would do that one. How do I write that? Well, number line. I'm greater than or equal to 0 and less than or equal to 8, so let me just write that there. There's my 0 and there's my 8 on the number line. They're both included, so they both get a square bracket, and it's all numbers in between 0 and 8, including 0 and 8. Interval notation, 0, 8, square brackets, included. Okay? If you wanted to do it separately, you just have two problems. You've got that one, and you've got this one. Just work them. Add 7, add 7. You got that one, x is greater than or equal to 0 if you read it backwards. And you've got this one, x is less than or equal to 8, and you got to put them together with an and, okay? Both of those things. Okay? There we go. All good. Let's look at part C. Okay, I'm just going to work this one together. I think that's the best way. -6, again, if I'm just reading it left to right, I'm going to read it as -6 is less than 3x is less than -3. If I'm reading it from x's perspective, I would say 3x is greater than -6 and less than -3. How do I solve this? I'm dividing by 3. Everywhere. There, there, and there. Everywhere. Okay, cancel. -6 divided by 3 is -2. And that's going to be a -1. So, x is greater than -2 and less than -1. Right? How do I write that? Well, number line. Okay. I am greater than -2 and I'm less than -1, so I'm right in here. Greater than -2 and less than -1. Not the equals. Strictly greater than, strictly less than, so like that. Okay? Everybody cool with that one? Let's look at part, oops, can you see that? Let's look at part D. Part D, what does part D have to say for itself? 17 is less than or equal to 5x plus 7 is less than or equal to 32. Again, let's kind of crank it simultaneously here. Subtract 7 everywhere. Subtract 7, subtract 7. Okay? What are we going to get here? We're going to get 10 is less than or equal to 5x is less than or equal to 25. Divide by 5 everywhere. There, there, and there. So I get 2 is less than or equal to x is less than or equal to 5. So how do I read that? X is greater than or equal to 2 and also less than or equal to 5. How do I show it? Well, on a number line, greater than or equal to 2, square bracket, less than or equal to 5, square bracket, all numbers in between, interval notation, just like that. Okay? All good? Alright. That's all she wrote for that example. Okay? Alright, let's take a look at example 5. I don't see anything different with example 5 on the surface. Let's just see what happens here. I've got 7 is less than 2x minus 1 is less than 5. Okay? Add 1, add 1, add 1. 8 is less than 2x is less than 6. Divide by 2, divide by 2, divide by 2. I've got 4 is less than x is less than 3. Think about this. Look at it from x's perspective. X is greater than 4 and it's also less than 3. Okay, well, how would I show such a creature on a number line or any other way? How can I be greater than 4 and also be less than 3 at the same time? It's an and relationship, right? If we took them separate. Sorry, I'm running out of room a little bit. But that's the problem. It's an and problem. And when I solved this one, what did I get? I got x is greater than 4, if I turn it around so I can look at it and read it that way. And what did I get here? I got x is less than 3, and I have this word and in between. X is greater than 4 and less than 3 at the same time. That can't happen, right? So when we get something like this that can't happen, there's no solution. Okay? Looks good, but then when we got to the solution, we said, there is no overlap there. There's nothing I can call a solution set. I cannot simultaneously be greater than 4 and less than 3 at the same time. Okay, so we throw that one out as a no solution. Okay? Sweet. Okay. Now, we didn't get one in the book here, which rather perturbs me, so I'm going to make up another one. We didn't get one in the book where we had to do the old switcheroo. Well, let me just make up a rather easy one here. 8 is less than or equal to negative 2 is less than or equal to negative 2x, pardon me, 20. Okay? So here's one where I'm going to divide by a negative. Divide by negative 2, divide by negative 2, divide by negative 2, and I'm making this one up, it's not in the book, but when we do that divide by negative, we got to switch the symbols, remember? We got to do the old switcheroo on the inequality. So do the division, 8 divided by negative 2 is negative 4, switch the symbol. Now that becomes a less than or equal to, if I'm reading it from x's perspective, this becomes an x, switch the symbol, and that becomes a negative 10. Okay? Does this make sense? Is this possible? From x's perspective, x has to be less than or equal to negative 4, and at the same time greater than or equal to negative 10. Can we do such a thing? Just to get a few numbers on the board here. X's perspective says I am less than or equal to negative 4, so including negative 4. So I'm going to be something over here smaller than negative 4, but at the same time, I'm going to be greater than or equal to negative 10, so I'm going to be to the right of negative 10, so yeah, that works. There's my solution. Interval notation, negative 10 comma negative 4. Okay, so the only catch was, just like with the regular inequality ones we solved, if you divide through or multiply through by a negative number, you must switch the inequality. So I had to switch them both, because I had two inequalities in the same problem. Okay, and when it's written this way, it's always an and problem. Okay, if I can't make the and make sense, then I had to throw it away like that last one. The and did not make sense on this last one, so I said no solution. Okay. Now you might get an or problem. Okay, an or problem is okay because you won't have a conflict with an or problem. Okay, in our next example, example 6 on page 362, is an or problem. Look what it says. X plus 3 is less than negative 2, or it gives you a whole separate problem here. X plus 3 is greater than 2. Okay, so there is going to be no worries that, wait a minute, this doesn't exist, this can't be possible, because of the word or. Okay, they're not expected to be able to happen simultaneously, otherwise it would say and. So let's easy peasy solve here. We get x is less than negative 5, or x is greater than negative 1 when I solve those two little problems. Everybody agree with that one? So I really have two solution sets here. How do I show less than negative 5? Well, that would be all numbers from negative infinity up to negative 5, but not including negative 5. Strictly less than. How do I show this? All numbers greater than negative 1, not including negative 1. Okay, that's how I would show it. On a number line, there's no overlap. There doesn't have to be an overlap. Let me make that to be 0. Negative 1, negative 2, negative 3, negative 4. Make that negative 5 there. Negative 6. Okay. How do I show it? All numbers less than -5, not including, so I'm going to have a parentheses here, and everything shaded to the left. That's all the numbers less than -5, not including -5. And now what about all numbers greater than -1, not including -1? It's going to be these. Okay, there is no overlap, but that's okay. It's an or problem. There doesn't have to be an overlap. If this were an and problem, we'd say, nope, there's no way to simultaneously be less than -5 and greater than -1 at the same time, so that we'd throw it away. But in this case, it's an or, so that's okay. Alright, so that's really all there is to that. Let's do one more, and then all of a sudden we're done with a whole other section again. Okay, these inequalities really are just almost identical to equations. We just are reporting the answer a little differently. We might have to do the old switcheroo on the inequality symbol, but otherwise, it's just good old equation solving like we've been doing. Okay, so I've got x minus 5 is less than or equal to -3, or x minus 5 is greater than or equal to +3. Two little separate problems. Let's work them. X is going to be less than or equal to +2, or x is going to be greater than or equal to +8. Okay, there we go. How do we show it? Less than or equal to 2 would be all numbers from -infinity up to 2, now, including the 2, so that gets a square bracket, okay, right? Less than or equal, so we get a nice square bracket. How about this? All numbers greater than or equal to 8, so including the 8, greater than all the way up to +infinity. That's how we would show that one. How do we do it on a number line? Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Less than or equal to 2. So start here at 2, including the 2 with a nice square bracket. All numbers less than goes that way, down to -infinity. Greater than or equal to 8, including the 8. Nice square bracket on the 8. All numbers greater than goes that way. Again, there is no overlap, and there doesn't have to be with an or problem. Okay? All right. That is it for Chapter 7, really, this section and the chapter. All right, all about solving equations and inequalities. So work on a bunch of problems, master these skills, okay? Chapter 8 takes equation solving into more kind of practical problems involving what we call formulas and proportions and variations. You'll see a little more practical examples, but it's just the same good old equation solving skills that you need to tackle those practical problems, okay? All right, stay tuned for more.